Hello everyone and welcome to my YouTube channel Everyday Lead Code. My name is Tirth Doshi and we are going to solve a very easy problem today uh, than the problems that we have solved earlier. Okay, the problem is search and sort position. Now, so given a sorted array and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. So you may assume no duplicates in the array. So there are no duplicates in the array that is given. And there's some sorted array. If the target is found, we are supposed to return the index of the target. So we can simply do a binary search there. The challenge is what happens if the target is not found? We still do a binary search. Now, will we do a binary search? We will end up at some point where my start is equal to end. I will come out of the while loop of the binary search and I will compare what is at index start and what is my target value. And depending on that, I will simply return start plus one or start. So that's the idea. So for example, if my target, so for example, in this example, let's take 1, 3, 5, 6. If I do a binary search here, the first would be, so the first middle point would be 3. The target is actually 2. Over here, I'm just writing my target. Target is 2. Because the target is 2, I'm here 1, 3, 5, 6. The first midpoint would be 1, and that is, so my target is lesser, so definitely the binary search space would be mid minus 1. So mid minus 1 would have been 0 and start would have been 0. So start, and I come out of the while loop. When I come out of the while loop here, I come out of the while loop. Okay, start is 0. Now I compare 1 and 2. If 2 is greater, I simply return start plus 1, saying that 2 has to be put at the position 1. Had I searched in the same example, if my target was 0, I would have said that put 0 over here at index 0. So I would have said that put 0 at my start or whatever end, because start and end would be equal when the while loop, when I come out of the while loop. So that's the idea over here. So the big picture over here is understanding that whenever you have a binary search and you start from this point, you compare, you go here or you go here, depending on the on your question, on your answer, I mean the comparison. You either go to the right search space, you either go to the left search space, as simple as that. Now here, what important understanding is that if you come out of the search space, I mean when you are out of the search space, that means I would be equal to j, or the start pointer is equal to j, and at that point I come out. I simply compare what is my target value. If the target value happens to be a greater number than the start, then I increment the start and return that start. Else I just return the start. In that example, it was if the target value was 0 or the target value was 2. So as simple as that. So it's just that, and I'll walk through the code. So I made start as 0, end as num dot size minus 1. That is just the pointers, just the normal binary search. I made the mid, saying that the mid variable will always store the midpoint of start and end. Now, if at any point I get nums of mid is equal to the target, I simply return my mid index. If it is greater, if my middle element is greater than the target, I have to go to the left search space. So end becomes start mid minus one, else it else what will happen? The start will become mid plus one. That is the right search space. That's the normal binary search. I come out of the loop when start is equal to the j. I do not return anything at that index. So I will come out of this only for two conditions. When one thing is I return the mid, or I do not return anything, but start has become equal to end. So I have to come out of the loop. When start has become equal to end, it means that I am closest as of now to the target. That if the target is greater, then I return a start plus one. If the target is smaller, then I just return a start. And that's the idea. It's a very simple problem actually. So yeah, if you like this video, please comment, like, and subscribe to this channel, and we'll be posting more videos soon. And have fun solving. Yeah, that's it.